And I thought maybe a nice thing to do would be to actually implement some passkeys, create one, use it to log into a pretend website, and actually sort of see some of the data that's going back and forth. I mean, it is a complicated system, but it also is kind of intuitive what happens, right? I've got a website that I created, one of my classic, unbelievably good looking, well-designed websites that I like to make, where we have both steps of the process. We have the creation of passkeys and we have the use of passkeys to log into things. The way that I've coded this up is you can see all the data going back and forth. That was my whole plan. And so we'll draw out what happens and then we'll look at this and we'll look at the code and we'll see what's going on under the hood. If we just start by looking at just how you create a passkey, right, or how your browser and your operating system create a passkey in, should we say, in combination with the server at the other end. So you want to log into a website, and that website is going to be running some kind of PHP or Node or some other kind of back end that does some code. Let's just say this is the server, right, which in my case is PHP. Now, we're over here on the browser, and in my case, this is obviously, JavaScript and HTML and things, right? So I'm just going to write JS. Full disclaimer, I neither program in PHP or JS. So, I've done my best to kind of haphazardly join this together. But anyway, let's suppose you log into a website, you type in your username, and you type in your password, right? This is what normally happens. And then they've now added this functionality to the website to create a passkey. That's when you get that prompt, right? You've logged in, would you like to create a passkey on this website? So the actual request to create a passkey starts with the client on the browser, right? So they're going to fetch from the server arguments for create args. And that's basically saying we want information on the server. What does the server need? Do they need the user to be verified? What kind of passkeys do they allow? This kind of stuff, right? So this goes off to the server, and the server creates those args. A lot of this is just JSON, JavaScript object notation, right? And we'll have a look at this. This gets sent back to the browser, and this is kind of where the passkey actually gets created. So the browser is going to call some JavaScript called navigator.credentials.create, right? And this function on any browser, that's what creates a passkey, right? And it needs these arguments to do that, right? So it takes the arguments about the server, it's going to create a passkey, and this will mean your browser then talks to the operating system, or talks to your password manager, or talks to your phone, depending on what website we're on and what we're using to browse that website, right? And that's where the passkey is created. So this will involve, a TPM.
That's the trusted platform module.
Yeah, or an operating system, software version, or a password manager, something along these lines. This will create a public and private key pair, which will be buried again in JSON, and then go back to the server for checks. And if the server's happy with it, it will store all this stuff in its database. Oops, that's a B, not a D, DB, right? And then it will respond with okay, right? Or some kind of, yeah, good job, you've made a passkey, right? So this is just the creation of a passkey. So I've coded all this up. Let's actually see some of this data, right? Because it is cryptographically complicated, but actually once you see it and you point out the main things, I don't think it's quite as bad as people think. So I've created this demo website. I've got 6 buttons. Normally you wouldn't see all the buttons, right? Most of this happens automatically. Most of this happens in 1 or 2 steps in the JavaScript behind the scenes. But I wanted to kind of hard code everything so that you could see each individual step happening. What I've done is I've got this index HTML with all the JavaScript involved. I've got various login and register PHP files that do most of the verification and checking of these credentials. I got a bit carried away and over-engineered it, primarily because I wanted to avoid too much library use. Because to do that, if you want to see all the individual stuff, you kind of have to do a lot of it yourself, right? Most libraries will do all this in a much better way than I'm doing, but they won't show you all the data. So the first thing we're going to do, we've just logged onto a website. Our username is demo user for this example. And our website is not Amazon or BBC, it's localhost, right? Because it's running on my laptop. And we're going to fetch the create argument. So this is going to ask the server what it's going to need from a set of credentials. So if we click this, this goes off to PHP and returns for us some JavaScript with various combinations of binary data and base 64 and all this other kind of business. But there's a few key things that we need. The first thing is the ID of the relying party. So that's the website we're on. The username of the user and a challenge. And that's basically to stop people from replaying creation things later, right? This challenge is going to be unique to this server. If I click fetch arguments again, it will get a new challenge. So if we go back to our little diagram, we've just created these arguments right here. and we've returned the arguments in JSON to our browser. The browser now needs to create the credentials. So if I click navigator.credentials.create, it's going to ask the operating system for a passkey. Now my password manager's popped up, I'm not going to use it. And then Windows pops up. Windows has said, I've been asked for a passkey for demo user on localhost. Would you like to do it? Now if I click cancel, it will just return failed, right? But I'm going to click OK. I'm going to type in my PIN code. It goes off and the trusted platform module on my computer will sign this, right? And different things will happen depending on where you're creating the passkey. And the data it returns back is quite complicated, right? Rather than look at every single field, I wanted to highlight the key stuff. So first of all, the client data, which is this thing down here, this is just information on what website it is, what was the challenge, right? And you can see that the challenge, this challenge GPBQ, is actually the same one that was sent earlier on in the fetch argument.
So that's almost like a kind of unique ID for...
It's a unique ID, right? And so it stops you, let's say, sending back to a server a challenge like 2 days later, or someone else doing it, or it stops any kind of situation where some of these messages are being replayed later, right? Because they have to be new. The attestation data is essentially all the signatures and certificate chains and things involved in verifying that this is a real TPM and it is the one that actually created these credentials. Normally, a lot of this attestation data is actually ignored by the servers, right? It's not that important. But consider a situation where maybe you're running a bank, right, and you want people to log in, but you want them only to log in with your official authenticator because you don't want other random people producing passkeys. You might verify that it's the exact hardware or software mechanism that you wanted inside here. So in this case, so the format is TPM. That means that a TPM was the thing that created these credentials, right? That's my TPM on my motherboard. I'm not convinced it's that new a TPM because it signed this message with SHA-1 hash, right, an RSA, which is deprecated. But for this attestation data, it's not that important.
Just to sign it is.
Yeah, it's signed with the private key that's baked onto the chip. Right? And so that can't be changed, and it doesn't matter that we've deprecated RSA in some sense, or RSA SHA-1, because there's not a lot we can do, right, short of replacing the motherboard. So I won't be doing that, I'm not that into it. Now we have a certificate chain, so this is the certificate for the TPM, and this is the certificate for Microsoft Intermediate Certificate, and there is a root certificate backing this up, and all operating systems will offer something like this. And then a couple of things that are interesting. This is the user presence and user verification fields. And what these are saying is that I actually had to type in a PIN to verify myself to get this to create a credential, rather than it did it automatically, right? Sometimes automatically is okay, sometimes we prefer that it isn't. And finally, this is the public key, right? So this is the elliptic curve DSA key, which will be sent to the server and stored and used to verify logins later. So we're going to return these to the server. And the service does a load of checks. So it checks, for example, that the user was verified. It checks the certificate chain. It checks the signature on this is all okay. So a TPM did actually sign it. And then it stores it in the database. So we've got the username is demo user. You'll notice that up here, when we created the credential, it was given a random credential ID. That's in base 64. It's just a binary string. The credential ID is the unique identifier for this public and private key pair. And it's so that the website can say, that one please, later. So this is what's got stored in the database. And actually you can see this, right? I've got my database up here. And if I select start from users, you can see it's all buried in the database, right? And so this PHP server can now obtain this information to verify people logging in later. And that's all that's required in creating a passkey. If I go into my Windows passkey settings, you can see I've got my new passkey in my Windows account. And I could have many more of these if I wanted to. Let's take a step back and away from that, and let's look at the next step of the process. So you've created a passkey, and now you come back later, you type in your username, and instead of logging in with a password, you have the option to log in with a passkey. What happens? Well, hold on. Can't tear and talk. The process is actually surprisingly similar. So we have our server and we have our client. So it always starts with the client. You just typed in your username, demo user or whatever on some website, right? And now the server needs to decide whether you're going to log in with a password or log in with a passkey. So we do a fetch of the get arguments. And these are very similar to the create arguments. They're basically saying if there's a passkey, the server will respond with what passkeys are available, what it wants to see, and the challenge token, which is really, really important. So this goes off to the server and makes the get arguments, and this comes back to the client. The client is going to call navigator, which I'm going to shorthand now because I fed up on writing it down, .credentials.get. And that is going to take the JSON that was returned by the server, in particular the challenge, and it's going to ask the operating system or the password manager or whoever it is that controls the passkey to sign that thing, right? That's going to go back for checks with the server, and then it's going to be a yes or a no, right? You logged in or you didn't log in, okay? So let's have a look at this process. So we've already created our passkey. We can scroll down, and we've got our next step, which is our actual authentication. So we're going to fetch the get arguments, and you can see we've got the challenge. We would prefer user verification, and because we know the passkey from the database, we can provide a list of allowed credentials. So that's saying that maybe you have more than one credential, you have more than one different device for that user. Like you have your phone has a passkey on it, your password manager has a passkey on it, right? You might have multiple in this list. In this case, I just have the one, and that, if you recall, is the ID we saw earlier. This goes to the browser, which then goes to the operating system and says, can you sign for me this challenge with this ID? So we're going to run navigator.credentials.get, and of course what's going to happen is immediately we're going to get hopefully a pop-up that says, would you like to use this passkey to log into this website? The fact that it's my slightly dodgy website, it's neither here nor there. It's Windows, it's perfectly happy to do this. There we go. Windows Security, sign in with passkey for demo user. So I'm going to type in my password again, and we're going to get back a signed challenge that proves that I had the private key, my device had the private key. So we still have our client data, which is the origin and the original challenge, and we still have the authentication data in this case, which contains things like the user verification is true. And the sign count, which is how many times this passkey has been used. That can be used to check whether someone has, let's say, cloned a passkey somewhere else, and you actually have used it 100 times, and they're trying to use it for the 10th time, something fishy going on. The most important thing is this signature here. This signature is the signed with the private key, client data and authentication data. So there's no way to fake this, right? My TPM is the only thing that has the private key. It's the only thing that could have responded to that challenge, right? And so now we send that challenge back to the server and we see what happens, right? And the server checks various things, but mostly it checks the signature. So we return a signed challenge and we verify the type of the message, which is webauthn.get. The challenge is okay, the origin is okay, so we know we're on the right website, we know we're the right username. The user was there and they were verified, and the signature is okay, right? And that's it, and the status is okay, so that is an effective login. So unlike a password where I send a string or a hash to a server, it hashes it some more and compares that hash with the database, it sends us that challenge, we sign it with something on our device, and that goes back, right? And that proves that we kind of have a password to get in, right? But I don't need to know what the password is. I don't know what the private key is. I can't get it off the TPM. And so all we know is the public key. It is a complicated system, but actually it's kind of neat, right? A lot of this data you don't ever see. You just see, look, do you want to create a passkey? Okay, do you want to use your passkey to sign in? And it all works kind of smoothly.
Look, I don't know what you've got planned for the year ahead, but if you're here watching a Computerphile video, then maybe it involves upping your game in computer science, coding, all that sort of stuff. And if you're serious about that, why not consider Brilliant? It's got a huge and ever-growing catalogue of courses and lessons, and these are game changers. They're interactive, superbly designed, and really take you on a journey. I love the way this looks, and it looks just as good on your phone as it does on a huge computer screen. You probably already know some of the basics, but this stuff can really take you to the next level. And it's also a great gift for people in your life who want to go deeper. To learn for free on Brilliant for a full 30 days, go to brilliant.org/computerphile or scan the QR code there on screen, and there are links down below. Our viewers are also being offered 20% off an annual premium subscription, which gives you unlimited daily access to everything.